Platelet activation is one of the effects of the venom in vipers. The purpose of my project was to analyse the effect of phospholipase A2 and snaclec on platelet activation. In order to do this, I had to purify the two proteins. Various chromatography steps were used in purifying the proteins. The one shown now is ion exchange. All the chromatography steps involved in the purification were gel filtration and reverse phase HPLC. The reason behind isolating the proteins was to be sure that the effect that they have is their own and not a different protein. After each chromatography step, I would take fractions and analyse the trace produced. Each of the fractions collected from the chromatography steps would undergo analysis by SDS page. The purpose of this was to confirm that the protein had been purified, and if not, another chromatography stage can be introduced. Here we can see the proteins being separated on the gel. And the final product. Each band within a lane signifies a different protein. In order to test for platelet activation, each of the fractions underwent a phospholipase assay. A mixture was made that included lectins. In the presence of phospholipase activity, the lectins will bind together. This will make the solution more see-through. A machine called a spectrophotometer was used to measure the absorbance of the solution. If the absorbance drops over time, then that means there is phospholipase activity present. As a final step to confirm that the purified proteins were snaclec and PLA2, they were analysed using mass spectrometry. There is some evidence that snaclec was involved in platelet activation. My results showed that when the purified snaclec was introduced to the lectin mixture, the absorbance did not change. This means that if snaclec is involved in platelet activation, it is not using its phospholipase-like activity.